So what do we do? The whole thing might seem quite tricky, complex, and it's not easy. I mean, this is a science in itself, and this is something that skilled remote sensors, have to deal with and have to work with all the time. And they have their favorite algorithms and their favorite parameters to work with, and considerations, and it will vary depending on what it is you're trying to do, which data you're working with. But obviously, most people aren't actually primarily remote sensors. They work with something else. They want remote sensing data, but they're doing something else. And a paper came out a few years ago in ecology to help ecologists to work with Landsat data. Various different, 7, 8, 9 wasn't out then. How do you work with Landsat data? And this is applicable also to Sentinel-2 data, for example. We have the same kind of problems. And they devised these graphics to explain what may or may not need to be done, depending on what level of pre-processing you've acquired from the provider. And we can see that we have all these different steps, and this nice little figure that tells us where we can place all these different terms and words, and we can think about the process of the light coming in and being reflected off of the surface of the Earth and then ending up at the sensor. And which corrections do we need to do? So we get our level 1 product, comes in as a digital number. This is what the computer has stored. And then what do we do to begin with? We need to start putting it in the right place. Take our image and put it in the right place on the Earth, so that we then know how much sunlight is going to be potentially falling on that point on the Earth's surface, and then converting and correcting for all these different effects. Or we just manage to get hold of something that's already processed and start working with it. All this part has been done, and we just start looking at, say, the topographic correction, because that quite often is left out. And a lot of products, not all products, some products do that for you, but you have to look at what you've actually been, what's been delivered to you, and you can see how much of this chain you need to work with. Generally speaking, if you aren't expert, if you feel uncertain, go for as high a level of processing as you possibly can from the provider, because all of this is an unnecessary job where things can go wrong, especially if you don't really know what you're doing. So even if it's not a perfect product, let somebody else do it, because usually it's at least knowable. Any errors that you have in it are known, because they'll be the same for everybody else, and it's published by the European Space Agency or by NASA, or whoever it is that's providing you with the data. So generally speaking, go for the highly processed stuff, or the relatively highly processed stuff, simply because you don't know what you're doing, and that's not a criticism. Basically, I don't know what I'm doing either. None of us do. We're all making good guesses, more or less good guesses. This is, as I said, this is science. This is research. This is something that is known by remote sensors. But if you're not a remote sensor, if you've not studied this and trained in this and worked with it, you're going to make mistakes. And somebody else can also make mistakes. Let them do that, perhaps, might be one word of advice. As I said, you then have known mistakes in your data. And if it turns out to be a problem, you can always go back, or other people can take your work and go back and redo it with the new knowledge of what that mistake was. Whereas if you've got your own processing chain and making your own mistakes, that might not be as obvious to everybody. So that's basically pre-processing, what to do. The last point down here: do not do change detection or multi-scene analysis without corrections. Again, if you've acquired some fairly well processed data, then you're good to go, generally speaking, if you accept these errors. Otherwise, you will need to do some processing. You can do change detection on some post-classification stuff. What that means is
if you consider that you've classified everything, put it into class data, so you've decided this is spruce forest and this is pine forest, you can do your change detection at that level afterwards. It's fairly coarse, but that shouldn't be too much of a problem. Whereas if you're doing a more nuanced study and you start doing it on processed data, you'll end up with some errors, probably, very likely. Yeah, so again, just summarizing the different levels. There's all this different terminology. You can look all this up. It's in these different product books describing the data, and hopefully you'll get something along these lines to work with. And again, Sentinel does the same thing. In fact, you won't actually get at a lot of this data. Quite often, you're looking at getting this stuff, or maybe this stuff. 2A, great. This is the best stuff for you as a novice user to work with.